Alright, so we're just going to do a brief introduction about the periodic table. A lot of people were working on putting the elements in some sort of a table and putting them in some sort of order, and then hopefully they could see patterns. Well, Mendeleev put all of the elements onto cards, and he put them into columns according to their properties, and then he ranked them by increasing atomic mass. And Mendeleev is pretty much given majority of the credit for coming up with the current periodic table that we have. Although he ranked them by atomic mass, there is a better way to rank them, and that's by atomic number. So when we came up with the periodic table, periodic law is when elements are arranged in order of increasing atomic number, that you're going to see a repetition of their physical and chemical properties. So basically, when you put them in order by their atomic number, you're going to see some patterns being repeated. You'll see that there are patterns in their chemical properties, whether they react to certain things, and their physical properties. So on your periodic table, you have periods and you have families. So your horizontal rows are your periods. You have 7 periods. And then your families or groups, they're called both, are your vertical columns. So vertical columns go up and down, horizontal go across. So when you're looking at your families or groups, they're going to have very similar physical and chemical properties, and they're identified by a number and a letter on most periodic tables. So 1A, 2A, 3A, 3B. Okay, so most of the elements on the periodic table are metals. So all of the ones that you see in yellow are metals. So even things like calcium, potassium, things that you consume, they're metals. The nonmetals are in green, and they're over here, except for this one. Hydrogen's weird. Those are the nonmetals, and then the things that are in between are the metalloids. So the ones that are on the staircase, those are your metalloids. Alright, so when we're talking about metals, metals generally have these characteristics. They're good conductors of heat and electricity, so they will allow electricity to flow through them, and they will also conduct heat very well. So if you put a pot onto the stove, it's going to heat up very quickly, which is why we use them for our cooking utensils. And they have luster, so that means shiny. They're shiny. They are ductile, which means I can stretch them out into a wire. They're malleable, which means basically they will bend under pressure. So if I take a hammer and I go hit your car, it's going to bend under the pressure. Metals will also have high melting point and boiling points. It's hard to get them to melt or boil. And they're usually hard. Not all of them are hard, but most of them are. And you'll see some metals that don't really follow all of these characteristics, but these are the general characteristics of most metals. Okay, so nonmetals are generally brittle, which means if I take a hammer to it, it's going to break under pressure instead of bend. They are not lustrous, so that means they're not shiny. They're poor conductors of heat and electricity, so they're not going to conduct electricity. They won't allow it to flow through, and they're usually used as insulators as opposed to metals. Metals you would never use as an insulator because it carries the heat so well. They have low densities, and they have low melting points and boiling points, so it doesn't take much energy to melt them or boil them. So metalloids will border the line on 2 sides, so they're going to be located on that staircase of your periodic table. Your metalloids consist of the following 7 elements. So boron, silicon, germanium, arsenic, antimony, polonium, And basically their properties are intermediate between metals and nonmetals. So maybe they're shiny and they conduct electricity, but they are brittle. All right, so I will see you in class.